If we look at almost any house built in North Carolina prior to 1940, not only a house, but textile mill or shop on Main Street, we find that it was designed for natural ventilation. Churches, all kinds of buildings had windows that could open to let natural cross ventilation take place. Often these houses or churches or shops have porches on the front to shade them from the hot midday sun, but allow that sun to penetrate into the building in winter when we need the warmth from the sun.
The power of nature has long helped lighten the load for humans. When our transportation needs became powered by pumps filled with petroleum products from around the world, we forgot about slower transportation powered by grass. And because our homes and industries are powered and lighted by electricity, available from wall sockets only a cord length away, we forget about firelight and water power that ground our grain. Most of us have never experienced the power of wind that first carried humans and their cargoes around the world. We love our modern conveniences, but the energy it takes to power them is becoming more scarce and expensive as populations grow. We don't want to return to the horse and buggy days or give up modern conveniences, but it is time to examine the power in nature found in abundance right here in North Carolina. First, let us realize that in every hour of every day, more energy from the sun reaches the planet Earth than is used by the whole human population during an entire year. Some of that energy is stored in trees, native grasses, and crops that can be used to make biofuels. Energy stored in lowly algae may someday provide substantial renewable sources of fuel for our economy. The wind that fills sails is still available on our coast and is in abundance in our mountain regions in western North Carolina. We are again learning to harness this cleanest of energy sources without harming bird populations and landscapes. The gravitational pull of the sun and moon team up to provide movement and energy in tidal flow. There are 2 high tides and 2 lows every day, and energy for the taking. Along with inland rivers which have long been harnessed, there are ocean currents like our Gulf Stream that may one day turn turbines to produce electricity. And let us not forget that the relentless waves of the Outer Banks that knock us down are also potential sources of energy. There is another source of energy that too many of us forget: conservation. When we use less, the energy we already have goes a lot farther. Frank Harmon is an award-winning North Carolina architect specializing in environmentally friendly buildings like the new complex at the North Carolina Botanical Gardens and the Prairie Ridge Classroom at the North Carolina Museum of Natural Sciences. We asked Frank about how we can all live and build smarter in a time of stretched resources while incorporating old and new technologies. I asked Frank about the best strategies for an energy-saving home.
For an office or a business owner, the most effective thing to think about in conserving energy and resources is to buy or build small. Don't build or buy more than you need. You know, the greatest use of energy is in heating and cooling space, and if we can find ways to use our spaces more effectively, in a house, for example, or in a showroom, that's the single most important way to be more sustainable. Next to that, I would say live close, live closer together. So much of our energy use is spent from going one place to another. Let's say we build the most energy efficient houses and factories and office buildings possible, but we still spend a great deal of energy going from one place to another. We've canceled out the advantage of building in that way. So I would say those two things. Build comfortably what you need, and secondly, live closer together.
I wanted to know what size house fits our needs.
The first thing I do is ask the client to keep a diary. How do you use your house and what rooms do you use during the course of a day, during the course of a week, or even a month? And what most of my clients discover to their surprise is that they typically use about 3 rooms 80% of the time. My question to them then is, why do you want to build 9 or 12 rooms when you spend most of your time in 3 rooms? In other words, how can we use space more effectively in your house? My goal is to have clients build smaller but better.
I asked Frank if he could do only 2 things to an old or new home to save energy. What would they be?
A homeowner looking for the best investment in saving energy should think about good insulation and better windows. These 2 things will do more to conserve energy than any other thing that they can do.
All of us want to be good stewards of energy resources, and we want the same rules to apply to government. To find out what government is doing to save energy, I went to a friend of 40 years, Julian Prosser, Assistant City Manager for the City of Raleigh.
The City Council, about 3 years ago, helped us establish some major priorities. One of those was saving energy in our buildings, existing buildings and buildings that we were considering building. One way we adopted to help that was to adopt a LEED standard for all of our new buildings, a LEED Silver standard.
Whenever energy conservation comes up, the term LEED is often discussed. It stands for Leadership in Energy and Environmental Design.
We think that gives us a way to focus not only on energy conservation, but on water conservation, the use of local materials, and other aspects of the LEED rating system to help us accomplish that energy savings objective.
I asked Julian about other energy-saving initiatives.
The city has had a methane mining operation at its landfill off of Highway 64 for about 15 or 20 years. That was one of our first major renewable energy initiatives. Since then, in more recent years, we've been working on solar applications, both solar thermal on buildings as well as renewable energy, photovoltaic solar power. We're also looking at innovative technologies for automotive and vehicular technology, particularly hybrids, and more recently plug-in hybrids. Those are efforts that we think will make a significant difference in allowing us to reduce our fossil fuel use. One of the experiments that we're taking on at our Neuse River wastewater treatment plant is sunflower seed production and the harvesting of the sunflower oil for biofuels purposes. We've developed a partnership with Piedmont Biofuels to explore the amount of biofuels we can generate from sunflower seeds. And we're very excited about the prospects of that opportunity.
Julian sent Exploring North Carolina to Southeast Raleigh to meet Tim Woody, reuse superintendent for the City of Raleigh. Tim took us for a walk in his garden, a field of energy, which may be powering a city vehicle near you.
The city does have an initiative to go green. We have lots of different projects throughout. We're working here at the wastewater plant. We're using some of the crops that we produce at our wastewater land application disposal sites to produce biofuel, biodiesel in particular. Several years ago, we commissioned a study with NC State University to particularly look at the potential for this site to produce a biofuel from biomass from our land application site. That study concluded that we have the potential to produce as much as 50,000 gallons of biodiesel a year. That biodiesel can be used to power equipment here on site, agricultural equipment, but also be used to power equipment such as buses, city buses, trucks, dump trucks, a number of equipment that the city uses in a day-to-day operation.
Raleigh, like all municipalities, must find a way to properly dispose of its sludge and solid waste. And sunflowers may offer a win-win solution.
The sunflowers, like many crops, have the capacity to assimilate nutrients, particularly nitrogen, which is probably the biggest concern that we have. Sunflowers have a higher than normal oil content for most crops. This site has the potential to produce much higher yields than a traditional farming operation. We have our biosolids that we produce here at the plant that we can land apply and serve as a fertilizer. We have our reuse water, highly treated wastewater that we can apply in the form of irrigation. And because of that, we're able to produce quite a number of bushels to the acre, much higher than you would in a traditional operation.
Tim called Exploring North Carolina several weeks later to invite us to the sunflower harvest. Remember, these sunflowers use up the nitrogen from solid waste of the sewage treatment plant and processed wastewater on land owned by the city of Raleigh to produce biodiesel fuel from sunflowers. This solves two problems: the proper disposal and utilization of solid waste and the need for renewable energy. I asked Julian about additional energy-saving initiatives underway in Raleigh and other cities.
One of our new renewable energy initiatives is solar. Both solar thermal that heats hot water for fire stations or other buildings where a lot of hot water load is present. Another is photovoltaic energy. And we're using some of our city facilities, particularly at our water plant and our wastewater plant, as well as other city buildings, to install PV. That photovoltaic energy is sold back to Progress Energy and goes back to the grid. And we are able to partner with them to enhance the understanding of photovoltaic resources in our area.
Raleigh, like many other North Carolina towns and cities, is planning new and larger solar arrays on public buildings. For more answers and more show and tell, Julian directed us to Robert Massengill, Assistant Public Utilities Director for the City of Raleigh.
The 0.25 megawatt solar array at the E.M. Johnson plant produces about 325,000 kilowatt hours annually. That's enough for about 30 homes. It's also equivalent to reducing carbon dioxide emissions by 264 metric tons. We're going to be building a solar array out at the Neuse River Wastewater Treatment Plant, and that will provide enough power to power 150 homes. Clean solar power helps us offset our power needs at our wastewater treatment plant, which requires a lot of energy to run our blowers, our pumps, and other mechanical equipment.
Does the amount of electricity generated by these solar projects reduce the expenses of a city like Raleigh? Or lower the bill for taxpayers? Only by a small amount, but they make it possible to better plan for the future.
On the surface, these may not appear like very large or beneficial projects, but what they help us do is learn lessons and determine how difficult it is to implement them on a larger scale.
Modern technologies which produce or save energy are being employed by cities, corporations, and universities across our state. Consider this large wind turbine producing energy at Appalachian State University. Can these new technologies be used in a cost-effective way in our homes? Frank Harmon had some insights.
Photovoltaic panels are an expensive investment to make on a building. It takes between 10 and 20 years for them to pay for themselves. There are much more economical ways that, as we've seen, energy can be saved, such as good insulation and windows that pay back much quicker than a photovoltaic does. However, in the larger scheme of things, if you take into account the true costs of energy, the cost of armies to protect our oil sources, the damage that we do to the Gulf of Mexico by extracting oil, then photovoltaics look like a very good investment.
Another major energy-saving technique being used by Raleigh and other cities, and by Frank Harmon in some of his environmentally friendly designs, is geothermal technology.
A geothermal system uses the more or less stable temperature of the earth, somewhere between 55 and 59 degrees, which is true across North Carolina, to heat and cool the building. In the summer, we're taking heat from the building and transferring it into the earth. And in the winter, we're drawing heat from the earth and using it to heat the building. So basically, a heat pump is a way of moving heat, pumping heat from one place to another. And one of the most efficient ways to do that is to transfer that heat with the earth.
Remember that with a geothermal system, in the winter, you are not beginning your heating process by warming 20 or 30 degree air, but with a constant temperature in the mid-50s from the soil beneath your house. In the summer, you don't have to start from scratch by cooling 80 or 90 degree air. Thus, a constant temperature in the mid-50s, maintained in the water of your geothermal system, can save energy and money.
There's a misconception that a geothermal system uses water from the earth. It does not. It's an entirely closed system. It has ordinary water in it. There's no antifreeze in it, and it's there permanently. Once you fill it up, it'll run for 30 years without being topped up. It can also be done in relatively small sites. A house with a third or even a quarter of an acre has enough space to drill 3 or 4 wells into the earth that this heat exchange system can be installed in. Incidentally, that's the major additional cost to a geothermal system, is simply drilling this hole in the earth. A well these days may cost $3,000, so as you can see, if you need 4 wells, it's about $12,000 plus some extra to connect them. So that's the additional cost. Otherwise, it's a perfectly normal heat pump system like you have in your house now. A geothermal system uses 40% less energy than a normal air-to-air heat pump system would use.
I have saved Frank Harmon's most revolutionary energy-saving ideas for last: light-colored roofs and strategically placed native trees.
One of the reasons you and I wear hats is because the majority of heat loss is through our heads, and the same is true in a building. That in summer, the heat gain from the sun through the roof is immense. Well, if we can have a light-colored roof, we're going to reflect the heat of the sun and thus save on energy. For over 300 years, farmers have been planting oak trees on the south and the west sides of their farmhouses. Why do they do this? Because farmers intuitively know that that's where the hottest sun comes from. And they want to block that sun in the summer because it heats up their house. And the greatest energy load in most of North Carolina is the cooling load, how to keep cool in, our hot, humid summers. So the farmer knows that by shading the house in summer, it's going to keep the house cool, but by planting an oak tree, which is deciduous and whose leaves fall in the autumn, it allows the sun during the winter to warm the house. Well, we can use those same devices today. If you have an existing house, pay attention to the exposure of the house, and on the south and west sides where you get most of your heat, if you don't have trees there already, plant them, especially native trees which are used to growing in North Carolina.
Remember that along with conserving energy, well-designed buildings also conserve water. It is easy to forget that when you water your lawns and flush toilets with stored water, you are using less energy. Water processed by cities and counties and pumped through miles of pipes requires energy. Saving water saves energy.
Studies show that less than 20% of all the water that we use is used for cooking or taking showers or flushing the toilet. All the rest goes for things like irrigation or washing the car or washing the dog. One of the most effective uses we can make to save water is to collect the water that falls on our buildings and even on our paved areas like our driveways.
When you combine the best of old and new technologies, solar panels, geothermal wells, big porches, light roofs, cisterns that collect rainwater, and mature deciduous trees, you have a LEED Platinum building, like the ones at the North Carolina Botanical Garden at Chapel Hill.
All of these initiatives together are really fairly significant. Each one by themselves is incremental and may not appear to have a substantial benefit to the city. But when we think in whole about the opportunities that we get when we combine these approaches, it's significant for us.
We've talked of a number of things today, each of which may seem small in itself, but together they could make an immense difference. After all, we all want to leave the earth better off than we found it.
Whether you own your own business, a home, or are just a citizen interested in energy independence for our state and nation, consider some of the advice you've heard today. Used alone, none of these technologies will solve our problems. But when combined, we tap the real power of nature while exploring North Carolina.